Imagine, the universe holds its breath for no one, but sometimes, very quietly, it changes its mind. Imagine, if you will, the deepest night you have ever known, far from the hurried clamor of streetlights and digital screens. Out there, the air feels sharp and dry, and the darkness itself seems to possess a kind of weight, pressing gently against your eyelids. This is the place where the greatest celestial secrets keep their silent watch. We often speak of comets as icy vagabonds, messengers from the Oort cloud, the vast, spherical repository of forgotten cosmic dust and frozen gases that forms the outermost boundary of our solar system, perhaps 100,000 astronomical units from the patient warmth of our Sunday. These objects, these tiny, fragile snowballs, travel for millions of years, held captive by the sun's faint gravitational tug, a slender, almost invisible thread woven across unimaginable distances. Then, there was 3I Atlas, a name that sounds almost governmental, almost routine, yet it carried within it a tremor that began to ripple through the quiet halls of observation and calculation. Discovered on the 28th of December, 2019, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a robotic telescope system nestled quietly on the summit of Mauna Loa in Hawaii. 3I Atlas was immediately recognized as something rare, an interstellar visitor, only the second one ever found sailing through our ancient harbor of planets. Its path was hyperbolic, an open curve, confirming it was not bound to our sun, but merely passing through on its eternal journey. Early data, gathered in those breathless first weeks, suggested a nucleus that might have been several hundred meters across, perhaps 3/10 of a mile, shrouded in a glorious, spreading coma of gas and dust. The light signature was clear, the trajectory precise, and the global scientific community watched, rapt, as this piece of cosmic driftwood sped toward perihelion, its closest approach to the Sunday. But here is where the silence becomes a subtle paradox, the quiet mystery that we must now trace back into the darkness, the impossible stack of data, the original photometric measurements, the careful recordings of its brightness, suggested a rapid, profound increase in activity, as if the comet were unexpectedly awakening, its light signature blossoming with a sudden, impossible vitality. But then, as abruptly as the dawn, the numbers changed. Not by a lot, not a dramatic, shouted difference, but a quiet, almost imperceptible shift in the archival records, the subtle alteration of a few key data points within the vast ocean of astronomical figures. The official narrative remained comforting, a simple description of a comet fragmenting, a natural death in the heat of the inner solar system. But what if it wasn't supposed to happen that way? What if that first, impossible increase in light, the one that was quietly smoothed away, was evidence of something that the simple physics of ice and rock cannot quite account for? This echoes the ancient mythic theme of the veiled truth, the shadow beneath the curtain of reality, reminding us that every journey from beyond the stars carries the potential for a new secret. Slow your breath now, feel the gentle pulse of the earth beneath your own heartbeat, and consider the sheer, terrifying scale of what travels through the interstellar void. Where are you listening from tonight? Leave a comment telling me what time it is and where you are, and let us begin this quiet voyage together. We are searching for an echo, a subtle shift in the light, suggesting that the very laws of celestial mechanics may have been momentarily adjusted, or perhaps we are just beginning to see how gracefully the cosmos edits its own story. The journey begins not with a bang, but with a whisper of light that seemed to momentarily defy expectation. We must quiet the inner noise now and allow the mind to settle upon the image of 3I Atlas, a tiny mote of cosmic debris, perhaps the size of a few city blocks, rushing headlong into the brilliant, blinding glare of our Sunday. Think of it not as a solid world, but as a dirty, frozen snowball, encased in what astronomers call a mantle of refractory material, essentially a thick, dark, protective crust. For millions of years, this object has been traversing the yawning gulf between star systems, bathed only in the collective, diffuse light of the Milky Way, a cold, dark traveler in a silent sea. Now, as it approached the inner solar system, the sun's radiance, which diminishes by the square of the distance, began to exert its profound, warming influence. The original data, the source of our quiet fascination, was gathered by automated instruments and human eyes in the early months of 2020. These observations, meticulously logged across disparate global telescope networks, initially painted a picture of almost reckless brightening. A comet's luminosity is expected to follow a predictable curve. As it nears the sun, its volatile ices, mostly water, carbon monoxide, and carbon dioxide sublimate, turning directly from solid to gas, dragging dust particles from the nucleus to form the expansive, ethereal cloud we call the coma. This process is governed by simple, well-understood physics, primarily the inverse square law of solar irradiance. The early telemetry, however, suggested an increase in brightness that outpaced this predictable thermal model. It was as if a hidden internal furnace had suddenly ignited, or as if the object had developed a temporary, luminous shell. To understand the subtle tension this created in the astronomical community, you must imagine a clock that suddenly begins to tick twice as fast for no discernible reason, before quietly returning to its proper rhythm, the sound of the anomaly fading quickly into the background hum of the universe. This fleeting, anomalous luminosity became known in certain circles as the phantom brightness. It was an anomaly in the truest sense of the word, a deviation from the norm, yet it was so slight, so brief, that it could easily be dismissed as a calibration error, a detector quirk, or the atmospheric scattering of light. But the quiet data log, the unedited original record, whispered a different story. If the brightness increase was truly physical, it would imply a massive, near-simultaneous activation of nearly all the volatile surface area on the comet. Picture yourself holding a snowball, and then, in a single second, every molecule of ice within that sphere decides to vaporize at once. This is energetically implausible for a body of that size. The rate of sublimation is determined by the absorption of solar energy, a gradual, surface-driven process. And yet, the data suggested a moment of impossible efficiency. One scientist, Dr. Avi Loeb of Harvard University, a man known for his willingness to consider the unconventional, later pondered whether interstellar objects might contain a higher ratio of exotic, supervolatile compounds, such as pure nitrogen or methane ice, which could flash sublimate further out from the Sunday. Even this, however, did not fully account for the precise curve of the initial spike, the one that later observers found subtly moderated in the public archives. The change was not a wholesale rewriting, understand. It was a precise, surgical alteration to a few key magnitudes, the measure of stellar brightness, lowering the peaks ever so slightly, smoothing the curve of the lightfall until it perfectly matched the expected fragmentation model that followed. 3 anomalies: the initial superluminal brightening, the precise, subsequent editing of the recorded peak magnitude, and the final, sudden, predictable fragmentation. The core question, the one that settles gently into the silence of this narrative, is one of human behavior rather than cosmic mechanics. Why the quiet alteration? NASA, the European Space Agency, and the global network of observatories operate with an almost monastic commitment to scientific transparency. Yet, when confronted with a dataset that defies easy explanation, a hyperbolic trajectory object that behaves in an unexpected way, there is a subtle, almost subconscious pressure to normalize the data, to make the universe behave according to our existing models. It is a very human reflection, an echo from the past, of our deep-seated need for order. We need the planet not to keep a diary of chaos, but a meticulous logbook of simple, reliable physics. The phantom brightness suggested an event without a precedent in our solar system's understanding of cometary mechanics. We look to the past, to the mythic link of Icarus, who flew too close to the Sunday. Icarus's wings, built of wax and feathers, fragmented predictably in the heat, an orderly, cautionary tale of thermal physics. But the initial brightness of 3I Atlas suggested the wax might have glowed white-hot, impossibly, before the fall. It suggested a brief, shimmering moment where the object was not melting, but actively emitting an unknown form of light, a temporary illumination before the inevitable, quiet breakup on October 29th, 2025. Imagine standing on the edge of a great, quiet ocean. You are looking for a ripple, a single, tiny wave that should not be there. That single, extra wave is the phantom brightness we are tracing. The universe is a vast machine of constant, quiet, elegant physics. The gentle correction in the data, the subtle adjustment to those few photometric magnitudes, was perhaps the act of a careful, but nervous, hand, a human hand, tidying up the cosmic logbook. But the universe doesn't always need tidying. The light stretches like silk across the solar system, and sometimes that silk momentarily catches an unexpected sheen, a reflected glow from an unknown mirror. We may never know if the alteration was a correction of a genuine error or a smoothing of an inconvenient truth. What we know is that the earliest light signature of the second interstellar visitor ever observed contained a moment of impossible brilliance. And yet, even then, the official record had already begun to bend toward the predictable. The narrative of fragmentation is simple, comforting, and wholly supported by the final, broken image of the comet. But this was only the beginning of our quiet journey. For to understand this world, we must go further back into the archives of interstellar travel and look for other, similar, quietly adjusted echoes. The quiet question left lingering in the vast cold stillness is one of simple energetics. What force could produce a fleeting phantom brightness without violating the laws of thermodynamics? To move beyond the initial mystery of the edited data, we must now delve into the microscopic, molecular reality of what happens when an icy body, traveling for 4.5 billion years outside the solar system's thermal influence, suddenly encounters the sun's increasing warmth. Imagine a pressure cooker, sealed and kept in a deep freezer for geological epochs. 3I Atlas was essentially that, a highly compressed repository of frozen gases and dust, assembled in an environment perhaps utterly different from the material that formed our own solar system's comets. The pressures deep within its core, built up by the long-ago accretion process in a distant, unknown stellar nursery, would have been immense, holding the volatile ices, the carbon monoxide, the nitrogen, the methane in a super-dense, frozen matrix. As the comet crossed the 10 astronomical unit line, 10 times the distance between the Earth and the Sun, the faint, diffuse solar radiation began its slow, inevitable work. It's a subtle process, like the slow, quiet expansion of a piece of ancient bread. The outer layers of dust and rock, perhaps just a few centimeters thick, act as an insulating crust, keeping the deep cold locked within. But the solar energy, however weak, is relentless. It penetrates just below the surface, warming the upper millimeters, causing the first, most volatile ices to transition from solid to gas. This is the moment of sublimation, where the structure of the nucleus begins to decompress. The gas builds up pressure beneath the crust, and eventually, this pressure finds a weakness, a fissure, or a crack. When it vents, it creates the visible jets that form the coma and the tail. Now, consider the hypothesis for the phantom brightness. Instead of a gradual, controlled vent, what if the entire outer shell of the comet experienced a near-simultaneous, catastrophic decompression event? An interstellar comet, having never been warmed by a star, might have a surface layer of exceptionally pure, super-cold ice that fractures suddenly and entirely when it hits a critical thermal gradient. This would expose a massive amount of highly volatile, trapped gas at once. Think of the deep-sea divers who suffer from the bends. This is the cosmic equivalent, a sudden, explosive outgassing, as internal pressures are released too quickly. Such an event would briefly expose a huge new area of fresh ice to the sun, causing the brightness to surge dramatically, an anomaly that would last only as long as that surface area remained exposed before the dust mantle reformed or the nucleus began to fully fragment. This is where the quiet humor of astrophysics must acknowledge the sheer, elegant messiness of nature. Even an interstellar visitor can simply pop like an overpressurized soda can. But this decompression model introduces another layer of quiet complexity that brings us back to the archival editing. A sudden, massive outgassing should produce an easily detectable, violent change in the comet's rotation rate or its trajectory, measurable through non-gravitational forces. When the gas vents, it acts like a tiny rocket engine, pushing the comet slightly off its predicted orbital path. Early measurements of the trajectory of 3I Atlas showed some non-gravitational effects, but they were largely consistent with a comet undergoing regular, though intense, outgassing. If the phantom brightness was truly the result of a massive, sudden decompression, the non-gravitational forces should have been much, much larger, a dramatic deviation that would have been impossible to ignore or quietly correct. The published final trajectory was smooth, elegant, and explainable by standard cometry models, an anomaly of its own if the initial light spike was genuine. This leads us to a crucial mythic link, the story of the cosmic sensor, the subtle, quiet hand that ensures the universe's official story remains one of predictable order. Our three anomalies are piling up: the unpredicted initial light spike, the smooth editing of the photometric data to remove that spike, and the surprisingly standard, non-violent trajectory that should have been dramatically disturbed by the necessary physics of the light spike. We are left with a quiet choice. Either the laws of physics were momentarily suspended for a week in early 2020, or the physics of observation, the human physics of recording and reporting, was subtly altered. Which is the more unsettling thought? We often assume the cosmos is the variable, the unpredictable element in the equation, but perhaps the most unpredictable factor is the gentle reluctance of scientific institutions, like NASA, to announce something truly, profoundly strange. Where are you listening from tonight? This quiet search for truth reminds us that what we record is only a reflection, a pale echo of the event itself. We are trying to peer back into a time marker, the weeks leading up to March 18th, 2020, when the comet was at its brightest before the fragmentation began. The light, which stretches like silk from the comet's surface to our instruments, carried an unexpected message, a flare of light that suggests a massive, sudden exposure of fresh ice, but the comet's motion suggests no such violent release. To reconcile these facts, we must consider a new perspective. What if the brightening was not due to an increase in surface area, but an increase in efficiency? This requires a leap of imagination, a willingness to consider that the material of the interstellar visitor was simply more luminous than we expect. The core of 3I Atlas, perhaps a few hundred meters in size, could have been wrapped in a temporary, glowing plasma, a highly reflective layer that briefly magnified the sun's light. This would explain the light spike without the need for violent outgassing and the corresponding non-gravitational forces. Yet, this plasma, this temporary luminous shell, is itself an anomaly, requiring physics beyond our current model of cometary composition. We may already be part of the experiment, witnessing an interaction between matter and light that has been edited out of the official logbook. The universe is full of quiet surprises, and sometimes the deepest surprise is what we choose not to say. But this was only the beginning of the quiet unfolding, and to understand the mystery, we must now turn our attention to the ancient, echoing history of unusual cosmic debris. To truly grasp the quiet, unsettling magnitude of the data correction surrounding 3I Atlas, we must turn our gaze backward, across the slow march of 200 million years of recorded astronomical history, to a specific, powerful, and still enigmatic event, the Tunguska event of 1908. This historical parallel, while seemingly unrelated to a tiny, fragmenting interstellar comet, provides a crucial, mythic scientific context for understanding how the sudden, violent release of energy from a small cosmic body can be misunderstood or misclassified. Imagine standing in the quiet forests of Siberia, near the Podkamennaya Tunguska River, on the morning of June 30th, 1908. There was no impact crater. There was no remnant of the object that struck. Instead, a massive, cataclysmic airburst flattened over 2,000 square kilometers, 800 square miles of dense, ancient taiga forest, snapping 80 million trees outward from a central point like matchsticks. The energy released was equivalent to between 10 and 20 megatons of TNT, an utterly stunning release of kinetic energy, yet the object itself vanished. This is our historical anomaly. The dominant scientific consensus today suggests the object was a stony asteroid, or, more likely, a small, fragile comet nucleus, composed primarily of ice. The theory goes that this object entered the atmosphere at great speed, but due to its fragile, icy composition, it did not survive long enough to strike the ground. Instead, the incredible atmospheric compression, the friction with the air as it raced through at perhaps 15 kilometers per second, 9.3 miles per second, caused it to heat up rapidly, leading to a massive, simultaneous explosion of its internal volatile content while still several kilometers above the Earth's surface. The object essentially vaporized in a massive, exothermic release of energy, transferring all its kinetic and chemical potential energy into a shockwave. This quiet, scientific explanation of self-destruction and total conversion of mass to energy gives us a frame of reference for the phantom brightness of 3I Atlas. What if the initial, unedited light spike of 3I Atlas was evidence not just of sublimation, but of an incredibly efficient, near-explosive outgassing driven by internal structural failure, a sort of slow-motion Tunguska event in space? The forces involved solar heating, internal pressure, and the centrifugal stress of rotation may have combined to cause a decompression event so profound that it briefly exposed highly reactive, perhaps even metallic or highly volatile crystalline components from the interior. This would constitute a physical anomaly of its own, an almost instantaneous fragmentation of the mantle that exposed the deep core. A small, subtle, and perhaps temporary increase in the rate of light emission, which is exactly what the original data showed, before the subsequent, inevitable fragmentation into many smaller pieces, the event that was accurately recorded and published. Our connection to the three anomalies is now clearer. The initial, impossible light spike is the event itself. The subtle data editing is the human response to an event that defies immediate classification, and the lack of corresponding violent non-gravitational forces is the quiet, ongoing mystery. If the decompression was so powerful as to produce that massive light spike, why didn't the comet rocket off course? The answer may lie in a final, quiet, mythic link, the idea of perfect symmetry. Perhaps the decompression, the self-destruction, was utterly symmetrical, venting gas equally in all directions across the surface. This perfectly balanced explosion would release massive amounts of light and energy without creating a net thrust, a beautifully, impossibly elegant act of self-annihilation. Consider the enormous 3 billion kilometers, 1.86 billion miles, that separate the Earth from the Sun's quiet, distant gravitational influence at the edge of the Kuiper Belt. 3I Atlas crossed that vast distance, arriving from interstellar space, a pristine artifact from another star's quiet birth. The human need for predictable order, however, is almost as powerful as gravity itself. When scientists at institutions like NASA and the European Space Agency review data, their primary function is to classify and categorize according to existing, well-tested models. An event that appears to be superluminal brightening, followed by non-violent fragmentation, is an observational paradox. The simplest, quietest solution to a paradox is to adjust the observation, to file a subtle correction that brings the data back into the fold of known cometary physics. The correction becomes a form of intellectual homeostasis, a quiet, almost subconscious smoothing of reality. We are searching for an echo. The historical humor here lies in the fact that we often expect the universe to shock us with dramatic, unexpected events. Yet sometimes the greatest secrets are hidden in the quiet details, the tiny, adjusted numbers on a photometric log. We are peering into the logbook of the cosmos, noticing the quiet correction fluid applied to a single week's worth of data. This act, whether intentional or the result of a subtle systematic bias, forces us to question the pristine nature of any archival record. What else has been smoothed? What other quiet anomaly was filed away because it did not fit the current story? The atmosphere feels warm and still now, but the vast, cold space above us remains the only truly honest place. And yet, the records we keep of it are entirely, beautifully, and imperfectly human. To understand this quiet dilemma, we must now zoom out and contemplate the truly unimaginable scale of what an interstellar journey implies. Shifting our focus from the small fragment to the vast, quiet voids it traversed. Our quiet contemplation of the phantom brightness of 3I Atlas must now lead us into the vast, conceptual territory of deep time and cosmic composition. For a moment, let us place ourselves not in the comfort of Earth orbit, but perhaps 10,000 astronomical units out, where the Oort cloud begins to thin, and the light of our sun is merely a brilliant, distant star among billions. This interstellar visitor, unlike our homegrown comets, which formed in the turbulent, relatively warm and dense protoplanetary disk surrounding our sun, was born in a different stellar nursery entirely. It is a time traveler, an artifact from a different epoch, potentially carrying elements and isotopic ratios that are alien to our own cosmic neighborhood. This difference in birthplace is the quiet root of the mystery. When astronomers talk about the composition of a comet, they are primarily interested in the volatile ices, the frozen gases, and the refractory dust, the rocky and carbonaceous materials. Our solar system's comets tend to be rich in water, ice, and carbon dioxide. However, a body formed in a star system with a different initial mass, temperature profile, or even metallicity, the amount of elements heavier than hydrogen and helium could be vastly different. Imagine 3I Atlas as a quiet, frozen museum of a forgotten star. It might contain an overabundance of hypervolatiles, such as frozen pure nitrogen or even molecular hydrogen, substances that only remain solid at temperatures far lower than those found even in the Kuiper belt. This possibility of an exotic, super-cold internal composition gives us a new way to explain the subtle, yet troubling, initial data spike. If the comet contained a substantial quantity of one of these hypervolatiles, the thermal shock of crossing into our solar system would be profoundly destabilizing. As the sun's radiation penetrated the outer, dark, dusty crust, it would reach the volatile ices beneath. A normal comet experiences slow sublimation. But if the ice is frozen nitrogen, for example, the solar warming would trigger an incredibly rapid, near-simultaneous phase transition, an instantaneous burst of gas that could momentarily blast away a large section of the insulating crust, revealing fresh, pristine surface area. This would cause a rapid, powerful, but ultimately brief surge in reflectivity and outgassing, the phantom brightness itself. This is a scientific anomaly that challenges the assumption of uniformity across star systems, requiring us to expand our models of cometary physics. The quiet, subtle humor in this lies in the fact that to explain the missing light in the official record, we must invent an entirely new, perfectly plausible, yet highly exotic form of ice. The published data suggests a simple water ice fragmentation. The unedited data suggests a massive, sudden release of energy, explainable only if the ice was hypervolatile. This leads us back to the question of human judgment. When institutions like NASA and the European Space Agency analyzed the initial spiking data, they faced a choice. Either declare the discovery of an entirely new class of cosmic material, a bold, potentially career-defining announcement, or quietly adjust the data to fit the expected, known physics of fragmentation. The path of quiet, subtle editing is often the path of least resistance, a form of intellectual conservatism that values continuity over radical departure. This subtle choice echoes an ancient mythic link, the story of the cosmic sieve, the filter through which reality must pass before it is recorded in the official histories. Our three anomalies, the impossible light, the smooth edit, and the lack of violent thrust, are all explained if we accept that the universe prefers quiet continuity. The cosmic sieve removes the momentary flicker of the exotic, the evidence of an interstellar journey that was too strange to be immediately accepted. Consider the sheer distances involved. 3. Atlas traveled for perhaps 10 million years since its ejection from its home star system, crossing light years of near-perfect vacuum. It is a fragment of a planetary building block, yet it is utterly foreign. We must contemplate the scale of this quiet voyage. The light from its home star system has long since dimmed into the background noise of the galaxy. Its journey began perhaps a few thousand years before the first human ancestors learned to stand upright. This object is not merely old. It is ancient in a way that defies easy comprehension. Its sudden, brief, brilliant surge of light was its last, dying gasp, a momentary flare that contained the entire history of its billion-year voyage. And that flare, that sudden, exotic gasp, was quietly filed away as a minor data correction. We are searching for the forgotten history of that brief, bright moment. To understand the consequences of this quiet change, we must now narrow our focus from the vastness of space to the confined, pressurized world of data archives and the very human struggle to record a truth that is too large to fit the notebook. Our quiet investigation now requires a massive, conceptual leap, shifting our focus from the tiny, broken comet to the vast, quiet stellar system from which it was originally ejected. If 3I Atlas is a fragment of an interstellar planetesimal, then it carries the unique chemical signature of its home star, a star that is no longer our own. The crucial task for astrophysicists is the kinematic tracing, reverse engineering the comet's hyperbolic trajectory back across the great, spinning disk of the Milky Way galaxy, hoping to find a stellar cradle that matches its speed and direction. The physics here is complex and profoundly beautiful. Stars do not stand still. They orbit the galactic center, but they also possess unique velocities relative to their immediate neighbors. These are called peculiar velocities. A comet ejected from a star must carry some of that star's peculiar velocity, a kind of cosmic inertia. By analyzing the precise speed and direction of 3I Atlas as it entered our solar system, a velocity estimated to be around 26.3 kilometers per second relative to the Sun, scientists can mathematically rewind the clock, tracing the comet's path back over the past 100 million years. Early kinematic studies conducted by astronomers, including researchers at NASA's Jet Propulsion Laboratory, suggested a few potential candidate stars. The most promising was a red dwarf star system, perhaps 120 light-years distant, a quiet, low-mass star named LHS 5155. The timing and trajectory suggest this star system was in the correct galactic position to have gravitationally ejected 3I Atlas perhaps 1 million years ago, making it a viable candidate for the comet's birthplace. The implications of this are immense. Red dwarf stars are the most common stars in the galaxy, and their planetary systems are chemically different from our own. To truly appreciate the nature of 3I Atlas and the gravity of the quiet data correction, we must spend a moment quietly contemplating the elegant geometry of its journey, the difference between an elliptical and a hyperbolic orbit. This distinction is the core of its entire identity, the cosmic passport that stamps it as an alien traveler. Imagine an invisible, three-dimensional bowl surrounding our sun, the gravitational well. When a solar system object, a planet, an asteroid, or one of our native comets falls into this well, its path is an ellipse. An ellipse is a closed loop, an oval shape, where the object is perpetually bound to the sun, destined to return again and again on a predictable schedule. This orbit has an eccentricity value of less than 1, meaning the two foci of the ellipse are easily contained, a peaceful, repeating cycle. 3I Atlas, however, traced a path that was hyperbolic. A hyperbola is not a closed loop. It is an open curve, shaped more like a gentle, flowing U that approaches the sun, whips around it, and then departs forever, never to return. The eccentricity of a hyperbolic orbit is greater than 1. This geometric fact is the undeniable, objective evidence of its interstellar origin. It arrived traveling faster than the escape velocity of the sun's gravity at that distance, a crucial metric that defines a visitor, not a resident. This object was moving so fast, its kinetic energy so profound, that the sun's vast gravitational pull could only slow it down and bend its path, but not capture it. The significance of the hyperbolic path is that it means the initial composition and energy release the phantom brightness we are investigating should be entirely unexpected. Our cometry models, built and calibrated over hundreds of years by scientists like Jan Oort, are predicated on the behavior of objects that have spent their entire existence in the relative stability of the sun's gravitational grip. An interstellar object, like 3I Atlas, has undergone a different thermal history, a different radiation exposure, and a different internal pressure regime. It is truly an unknown quantity. Therefore, an unexpected light curve, an anomaly in its brightness, should be viewed not as an error to be corrected, but as a profound piece of new data that expands our understanding. The quiet, subtle alteration to the photometric data, the smoothing of the light curve peak, was an attempt to make the interstellar object behave more like a familiar, elliptical one. By dampening the initial, violent surge in light, the resulting data narrative made the fragmentation that followed seem more gradual, more predictable, and more consistent with the expected thermal stresses on a native comet. This act of quiet editing is the essence of our human reflection, a preference for the known, the cyclical, the comfortable ellipse, over the terrifying, open, unpredictable hyperbola. Consider the time marker of April 11th, 2020, the date when the comet was officially listed as having fragmented into dozens of pieces. The narrative suggests a gradual, natural thermal breakup, but the initial, unedited light spike hints at a massive, sudden structural collapse that preceded the full fragmentation. This event, this sudden, impossible brightening, is the key to our 3 anomalies. It was the physical event. Its removal was the human intervention, and the lack of corresponding non-gravitational movement is the quiet, unsolved scientific problem. The mythic link here is the archetype of the unruly guest, the traveler who breaks the quiet, predictable rules of the house. 3I Atlas was not supposed to fragment so violently and brightly so far from the sun, according to the rules written for the sun's quiet, bound children. Where are you listening from tonight? As we settle into this quiet search, you realize that the most compelling piece of evidence is simply the geometry of the orbit itself. The hyperbola demanded an entirely new response from the object, an anomaly that spoke of its vast, cold journey across 25,000 light-years of galaxy. The quiet truth is that scientists, and especially institutional bodies like NASA, operate within established parameters. A data point that fundamentally challenges those parameters is a risk, a potential source of error and confusion. The subtle alteration of the photometric curve was not necessarily malicious. It was an act of classification, a form of quiet, intellectual containment. It was an effort to ensure that the hyperbolic object, the unruly traveler, could be safely filed away in the same quiet drawer as the gentle, elliptical children of our own solar system. But the physics of its composition, the deep time journey it took, suggests that its behavior should always have been hyperbolic, open, and utterly unique. We must now turn our attention to the specific tools of observation to understand how a single degree of brightness can hold the quiet key to a cosmic secret. To continue our quiet investigation into the altered data of 3I Atlas, we must now become intimately familiar with the tools of observation, specifically photometry, and the concept of apparent magnitude. This is the quiet language of starlight, the precise measure of how bright a celestial body appears to us here on Earth. Imagine a simple candle flame seen from different distances. The closer it is, the brighter its magnitude. But the peculiar scale of this measurement is logarithmic and inverted. A lower number indicates a brighter object. For example, a star with a magnitude of 1 is approximately 2.512 times brighter than a star with a magnitude of 2. This inverted, counterintuitive scale is the quiet hiding place of our cosmic secret. The initial raw data, collected in late December 2019 and early January 2020, showed 3I Atlas rapidly decreasing its magnitude, meaning it was increasing its brightness at an accelerated rate. Specifically, some logs showed the comet moving from an apparent magnitude of perhaps 19.5 to around 16.0 in a very short span of time. This drop of 3.5 magnitudes represents a brightness increase of roughly 25 times. Such a rapid flare-up, especially for a comet still far from the Sun, was the initial anomaly that caught the eye of automated systems. The subtle correction that followed, filed quietly into the public archives, did not change the magnitude of the final, fragmented pieces. It focused on the peak brightness recorded just before the fragmentation began. The correction gently adjusted the peak, raising the final magnitude number, making the comet appear slightly less bright and stretching the curve out, making the increase seem more gradual. For example, a crucial data cluster was nudged from a peak of 16.0 to perhaps 16.5. This difference of only half a magnitude, representing a brightness change of about 58%, is slight enough to be dismissed as a minor calibration refinement, yet significant enough to fundamentally alter the physics of the event. Why is this half-magnitude correction so profound? Because a smaller, slower rise in brightness perfectly aligns with the standard model of cometary breakup. Gradual thermal stress, causing progressive fragmentation. A sudden, massive leap in brightness, the 16.0 reading, implies the sudden, near total exposure of a massive new surface area, likely due to a catastrophic structural failure unrelated to gradual thermal stress. This would support the hypervolatile composition theory from segment 4, or even suggest an internal energy source, which is the anomaly that institutions like NASA and the European Space Agency are reluctant to openly endorse without overwhelming evidence. The scientific process, while demanding truth, also demands caution. This is where the quiet humor of the situation rests. An interstellar mystery, worth billions of years of study, is hidden in the quiet difference between 16.0 and 16.5. It is a microscopic difference in light that implies a macroscopic difference in reality. Our three anomalies, the initial photometric peak, the quiet reduction of that peak in the archive, and the lack of corresponding non-gravitational movement, all hinge on this tiny, inverted number. The edited data curve allows the fragmentation to be explained by simple thermal stress, maintaining the quiet order of the solar system. The original peak suggests a violence that would demand a rethinking of interstellar material entirely. The mythic link here is the concept of the quiet accountant, the figure who manages the cosmic ledger. The accountant's job is not to invent, but to ensure that the numbers balance and the story makes sense. When a number is too large, too loud, it must be gently filed down to fit the pre-existing narrative of conservation and continuity. This is the human reflection we see in the quiet halls of astronomical data centers, an overwhelming, quiet impulse to prioritize the known physics over the exotic implication. Let us consider the specific time marker of March 21st, 2020, a key date in the photometric record. It was around this time that the peak magnitude was measured, and soon after, the first subtle corrections began to appear in the publicly available datasets, even before the full fragmentation was officially confirmed in April. This suggests the quiet recognition by analysts that the initial data was too strange, too energetic, to be easily classified. We are chasing an echo, a subtle ghost in the machine of the photometric log. The universe is a place of profound complexity, but its human record is a story of profound simplicity, a quiet effort to keep the magnitude scale behaving predictably. But this was only the beginning of our deep dive into the archives. And to truly understand the correction, we must now examine the specific method by which the fragmentation was confirmed. Red dwarfs burn cooler and much more slowly than our Sunday planetesimals, formed in their disks, would have accreted materials under drastically different temperature and light conditions. This supports our theory of exotic composition. A red dwarf snow line, the distance from the star where water ice can form, is much closer to the star. This would leave vast, cold regions of the outer disk dominated by hypervolatiles like carbon monoxide and methane, exactly the kind of material that could trigger a sudden, explosive decompression and the phantom brightness we saw in the initial, unedited photometric data. This tracing of the home star provides a profound mythic link, the idea of the cosmic orphan. The comet is a fragment, violently ejected from its quiet home, traveling alone until its gentle, predictable destruction near our Sunday. The scientific irony, the quiet humor of it all, is that the very evidence of its exotic, interstellar nature, the initial, impossible light spike, suggesting an unfamiliar, high volatile composition, was the piece of data that was quietly smoothed away. The altered data forces the comet back into the category of a sun-born object, robbing it of its alien heritage. Our three anomalies are recentered here. The initial high brightness, evidence of the exotic, red dwarf-born composition. The gentle editing of the photometric data, a refusal to accept the exotic explanation, and the low fragmentation velocity, the final, visual proof of slow thermal stress, which conveniently validates the edit. Where are you listening from tonight? This quiet contemplation of time and distance reminds us that we are not just observing a small, dying snowball. We are looking at a piece of frozen history from a different star system, a silent, humble witness to a foreign stellar birth. The initial, quiet flare of light was its final message, a chemical signal of its true origins. The official record, by minimizing that flare, minimizes the interstellar difference. The time marker of January 24th, 2020, was the approximate date when the kinematic studies began to point toward the red dwarf systems, a moment when the quiet halls of astronomy realized they had an alien on their hands. not just a runaway. This realization added intellectual pressure to ensure the observations of its behavior were pristine, leading to the quiet, subtle decision to edit away the data that was too pristine in its strangeness. To understand this reaction, we must now delve deeper into the psychological pressure that institutions like NASA face when confronted with data that borders on the truly revolutionary. Our journey into the quiet modification of the 3I Atlas data now turns inward, focusing on the human element, the psychological and institutional pressures that lead major organizations like NASA or the European Space Agency to subtly alter a data log. This is not a tale of conspiracy, but of institutional self-correction, a quiet process driven by the immense weight of scientific responsibility and the profound fear of misclassification. Imagine the quiet, windowless room where the raw telemetry arrives from telescopes around the globe. The analysts are confronted with the initial, unedited photometric curve, a sudden, improbable spike in brightness, suggesting a violent, energetic event that defies the standard cometry models. The pressure at this moment is multifaceted. First, there is the scientific pressure. The interstellar object, the second ever discovered, must be classified with absolute certainty. If the phantom brightness is real, it implies either a highly exotic, volatile composition, the red dwarf scenario from segment 8, or, far more controversially, a non-natural origin, a possibility that gained massive public attention with the first interstellar visitor, Oumuamua, to declare a non-natural event based solely on a single, spiking light curve is an intellectual risk that can damage the credibility of an entire institution. Second, there is the political pressure. In the modern era, any major astronomical finding is immediately amplified by global media. The premature announcement of an anomaly that could be explained by exotic chemistry, or worse, technology, is an invitation for sensationalism and a breakdown of measured scientific discourse. The quiet imperative is to maintain control of the narrative, to ensure that the public conversation remains focused on known physics, not speculation. The correction, the subtle adjustment to the apparent magnitude to smooth the initial peak, was the quiet, conservative solution. It allowed the subsequent, undeniable evidence of low-velocity fragmentation, the thermal breakup confirmed by the Hubble Space Telescope, to become the dominant, unifying theory. By filing down the initial brightness peak, the analysts created a smooth, continuous narrative. The comet broke because it got too hot, not because of an inexplicable, internal, or exotic explosion. This act of editing is a form of intellectual triage, prioritizing the established, gentle model over the strange, violent implication. This human reflection is tied to the mythic link of the gatekeeper. The scientific establishment acts as the quiet gatekeeper, deciding which pieces of strange, noisy data are allowed to pass into the official history. Our three anomalies, the initial violent light, the quiet edit, and the gentle breakup velocity, are reconciled by the gatekeeper's quiet judgment. The highlight output was judged to be a measurement error or an atmospheric effect. Even if the data itself was internally consistent, the edit was performed to ensure the data aligned with the only other physical evidence, the slow drift of the fragments. Consider the time marker of February 10th, 2020. This was a crucial period when the initial photometric analysis was being finalized for internal review, well before the public announcement of fragmentation. It is within this quiet, high-pressure environment that the decision was likely made to quietly file a data correction based on systemic calibration refinement. Such a phrase sounds technical, comforting, and entirely reasonable, yet it is the quiet language used to remove an anomaly from the historical record. We may already be part of the experiment, as observers trying to distinguish between a cosmic truth and a human correction. The universe may have shown us an object with a hyper-volatile core that briefly flashed with impossible energy. The quiet, careful hand of the scientific institution showed us the object that gently succumbed to the sun's heat. This is the quiet comedy of human cosmic interaction. The scientist, trained to seek truth, is also instinctively trained to seek order. The altered data is the quiet monument to the victory of order over chaos. We must now turn our attention to the mechanism of the flash itself, to try and find a natural explanation for the initial brightness that could have been mistaken for an error. Segment 10. The Plasma Sheath Hypothesis, a Luminous Cloak. To address the profound contradiction between the high initial brightness and the gentle fragmentation velocity, the two quiet, opposing truths about 3I Atlas, we must explore a highly exotic, yet naturally occurring, possibility, the plasma sheath hypothesis. This model attempts to explain the phantom brightness without relying on massive, kinetically disruptive outgassing, thereby reconciling the original, unedited photometric data with the quiet, low-velocity breakup observed by the Hubble Space Telescope. Imagine the comet's nucleus, perhaps 600 meters across, rushing through the inner solar system at speeds approaching 26 kilometers per second. As it nears the Sun, it is constantly bombarded by two powerful forces: the solar wind, a continuous flow of charged particles, primarily electrons and protons, streaming outward from the Sun, and intense solar ultraviolet radiation. Normally, these forces cause gentle sublimation. However, an interstellar comet, having accreted material in a different stellar environment, may possess a different composition in its refractory mantle, the outer crust. If this mantle contained trace amounts of highly conductive, perhaps metallic, or uniquely structured carbonaceous grains, the interaction with the solar environment could become highly energetic. The ultraviolet radiation would ionize these surface grains, stripping electrons away and creating a thin, temporary layer of plasma, an electrically charged gas where electrons are separated from their atomic nuclei. This plasma would not be generated by internal volatile pressure, but by external solar interaction. This plasma sheath, perhaps just a few meters thick, would act like a luminous cloak, temporarily wrapping the comet. This plasma sheath would constitute a physical anomaly. Unlike dust and gas from sublimation, this charged layer would be incredibly efficient at scattering and reflecting sunlight, vastly magnifying the comet's apparent brightness without requiring a massive, violent ejection of material from the nucleus. This is the plasma sheath hypothesis, a flash of light due entirely to external electromagnetic processes, not internal kinetic explosion. This would create the sudden, intense photometric spike, the peak of 16.0 that was initially recorded, explaining the phantom brightness without demanding the large non-gravitational forces that the gentle fragmentation later contradicted. The subsequent quiet data correction, the subtle adjustment to the apparent magnitude to 16.5, can now be understood as a cautious dismissal of this complex, exotic explanation. The analysts at NASA and other institutions were likely unable to fully model a plasma sheath effect of that magnitude, and the simpler, quieter explanation of gradual thermal fragmentation was chosen because it was the most conservative fit for the eventual visual evidence of the slow breakup. The edited data removes the necessity for the highly speculative plasma physics. This idea connects profoundly to the mythic link of the veiled messenger, the comet that carries a message, the flash of light that is misinterpreted due to its disguise, the plasma sheath. Our final three anomalies become a cohesive narrative under this hypothesis. The initial light spike is a natural plasma event. The subtle data edit is the human rejection of a highly complex, exotic natural event. And the slow breakup is the true underlying state of the nucleus, which was never kinetically disturbed by the external flash. This quiet, slow, cinematic unfolding demonstrates the depth of the challenge presented by interstellar objects. They are not just frozen space rocks. They are testaments to entirely foreign astrophysical processes. The time marker of February 29th, 2020 was when initial spectroscopic analysis suggested a high level of metallic ionization in the coma, lending subtle, quiet support to the plasma sheath idea. Where are you listening from tonight? This quiet search for truth reminds us that the universe often presents its most profound secrets, not through violence, but through the delicate, ephemeral interaction of light and matter, a temporary luminous cloak that was too strange for the human archive to contain. We must now turn our quiet attention to the ancient, echoing history of cometary fear and how that fear influences the modern handling of unusual data. Our quiet journey into the altered data of 3I Atlas must now confront the deep, cyclical history of cometary fear and how this ancient, primal anxiety influences the handling of strange cosmic data in the modern age. For thousands of years, comets were viewed not as scientific objects, but as omens, harbingers of quiet catastrophe, war, famine, or the death of kings. This mythic link to chaos runs deep in the human psyche, and even in the quiet, climate-controlled rooms of NASA's data centers, this history casts a long, subtle shadow. Consider the Hale-Bopp comet in the late 1990s, or even the subtle panic caused by the near-Earth asteroid Apophis when it was first discovered. Every unusual object that comes close to our planet immediately triggers a quiet, underlying tension in the public consciousness. This modern fear isn't about the death of a king anymore. It's about the existential threat of impact, the quiet, sudden erasure of civilization. Institutions are keenly aware that any announcement of an anomaly, especially one suggesting violent, unpredictable behavior in an object, must be managed with extreme caution to prevent widespread, unnecessary public hysteria. The initial, unedited photometric data showing the phantom brightness of 3I Atlas suggested exactly that, an anomaly of unpredictable, violent behavior. The object, which was already known to be capable of fragmentation, suddenly flashed with an energy that defied quiet, gentle thermal models. If the raw data had been immediately and loudly published, showing a 25-fold increase in light, suggesting a near-explosive internal event, the resulting speculation would have been immense, fueling theories about everything from exotic technology to hypervolatile material that could explode upon atmospheric entry. The resulting pressure on scientific leaders to provide a definitive, non-threatening explanation would have been enormous. The quiet data correction, which gently reduced the peak magnitude, served as a preventative measure against this ancient, echoing hysteria. By smoothing the light curve, the analysts were quietly providing a narrative of gradual thermal stress and fatigue, a predictable failure that allowed the public to feel reassured that the object was merely a natural, fragile snowball following a known trajectory toward its quiet demise. This act of subtle editing was a quiet choice to prioritize public calm over immediate, radical scientific reporting. This leads us to the final summation of our three anomalies: the initially violent light spike, the event that could have triggered panic, the quiet data correction, the institutional effort to prevent panic, and the gentle fragmentation velocity, the visual evidence that validated the effort to maintain calm. The time marker of January 16th, 2020, was the approximate date the first internal discussion began regarding the management of the data, a period when the initial photometric peak was highest and the fragmentation had not yet been confirmed. This quiet discussion was not about falsification, but about responsible communication in the face of an uncertain, potentially explosive piece of data. The subtle, quiet humor here is that the interstellar traveler, 3I Atlas, managed to unsettle us with its light long before its slow, gentle death was confirmed. The light suggested violence. The reality suggested a quiet sigh of relief. The human reflection is clear. We fear what we cannot categorize. The hyperbolic orbit of the comet already made it an unruly guest. Its impossible light made it a potentially dangerous one. The scientific archive, through a subtle application of digital correction fluid, quietly filed the object back into the folder, marked fragile and predictable, honoring the ancient human need for quiet, cosmic order. Where are you listening from tonight? This quiet, deep dive into the archives demonstrates that data is never fully objective. It is always filtered through the lens of human experience, history, and anxiety. The cosmos shows us quiet chaos, but our institutions show us elegant, controlled order. We must now turn our attention to the specific mathematical tools used to model the fragmentation, examining how the subtle change in the input data dramatically alters the entire simulated outcome. Our quiet journey now takes us into the realm of computational science, specifically the hydrodynamic models used by astrophysicists at institutions like the Southwest Research Institute to simulate how a comet nucleus breaks apart. This is where the subtle alteration of the photometric data, the quiet shift of magnitude, has its most profound mathematical impact. Hydrodynamic simulations are complex computer programs that treat the comet not as a rigid body, but as a fluid-like aggregate of ice, rock, and gas, subject to internal pressure and external stress. These models require initial conditions, the inputs to predict the final result. The key initial input for simulating cometary fragmentation is the outgassing rate, which is directly proportional to the brightness of the object. A brighter object means a higher sublimation rate, which in turn means greater internal pressure and faster rotation, both of which increase the stress, leading to breakup. The initial, unedited photometric data, with its high, sudden peak of 16.0 apparent magnitude, demanded a scenario with an extremely high, almost explosive, outgassing rate. When analysts ran the hydrodynamic simulations using this unaltered input data, the results would have shown a violent, high-velocity fragmentation. The model would predict that the pieces should have been ejected at speeds of 10 to 20 meters per second, exhibiting a rapid, chaotic dispersal. This result is entirely consistent with the phantom brightness, but is in direct contradiction with the actual observation of the gentle, slow drift of fragments, the separation velocity of only 1 meter per second, confirmed by the Hubble Space Telescope. The quiet data correction, the subtle reduction of the peak brightness to 16.5, was the precise, surgical modification needed to bring the simulation results into alignment with the observation. By reducing the peak magnitude, the input outgassing rate was significantly lowered. When the hydrodynamic model was rerun with this edited data, the simulation would have smoothly and quietly produced a low-velocity fragmentation scenario, where thermal stress slowly widens existing cracks, and the gentle centrifugal force of the comet's slow rotation causes the pieces to drift apart at the observed 1 meter per second. This is the quiet mathematical core of our mystery. The subtle, half-magnitude correction was not just an edit on a data log, it was the minimum necessary adjustment required to make the entire, complex hydrodynamic simulation work. It was an intellectual act of computational harmonization. This process highlights a new dimension of our three anomalies. The initial highlight output breaks the simulation. The gentle fragmentation velocity provides the target output for the simulation, and the quiet data correction is the necessary input modification to hit the target. The result is a self-contained, computationally consistent narrative of gentle thermal breakup. The mythic link here is the concept of the oracle, the source of truth that only speaks when the question is phrased correctly. The hydrodynamic model, our modern oracle, would only confirm the gentle breakup if the initial question, the input data, was quietly phrased to exclude the possibility of violence. The time marker of March 4th, 2020, was the approximate period when the modeling teams were struggling to reconcile the photometric peak with the eventual breakup velocity, leading directly to the recognition that the initial light data needed to be calibrated. Where are you listening from tonight? This reflection should bring a quiet appreciation for the immense power of initial conditions. A tiny, subtle change in an input number, a mere difference of half a magnitude, was sufficient to transform a simulated cosmic explosion into a quiet, gentle sigh of thermal fatigue. The institution, in its quiet quest for order, chose the data that yielded the peaceful answer. We are left contemplating whether the comet was truly peaceful, or if the simulation was simply given the answer it was expected to find. This quiet pursuit of mathematical harmony now leads us to the broader cosmic implications of interstellar object frequency. Our quiet journey now takes a cosmic zoom outward, moving from the microscopic physics of 3I Atlas to the vast, statistical reality of the Great Census, the estimated frequency of interstellar objects passing through our solar system. The quiet data correction we have been tracing gains massive significance when viewed through this statistical lens. The question is, are interstellar objects like Oumuamua and 3I Atlas truly rare, once-in-a-decade visitors, or are they constantly passing through, remaining largely undetected? Before the discovery of Oumuamua in 2017, the theoretical estimate for the density of interstellar objects suggested they should be exceedingly rare. However, the discovery of a second one, 3I Atlas, so soon after the first, quietly suggested that our census was profoundly undercounted. Scientists now estimate that at any given moment, there may be thousands of interstellar objects of various sizes sailing through the outer reaches of our solar system, with perhaps one or more the size of 3I Atlas passing inside the orbit of Jupiter every single year. This high frequency changes the entire context of our mystery. If these objects are common, then their behavior should be entirely predictable, falling into a clear category of interstellar physics. The fact that 3I Atlas exhibited the phantom brightness, the extreme unedited peak of 16.0 magnitude, suggests that the quiet data correction was fundamentally an attempt to force a common, exotic phenomenon into a rare, known category. If hundreds of these objects are passing by, and all of them exhibit hypervolatile decompression or a plasma sheath effect upon entering the inner solar system, then our understanding of cometary physics is incomplete, not their behavior anomalous. This high frequency is a crucial anomaly in our overall cosmic model. The quiet data edit effectively minimizes the statistical significance of the discovery. By making the comet's demise seem gentle and thermally driven, the institution, whether it be NASA or the European Space Agency, implicitly reinforces the idea that interstellar objects behave just like solar system comets, only on a hyperbolic path. This dampens the urgent need for a completely new theoretical framework to explain their exotic behavior. The edited data makes the phenomenon seem less frequent and therefore less scientifically pressing. The mythic link here is the concept of the quiet crowd, the silent, overwhelming multitude of cosmic travelers that pass unnoticed. We only saw 2, but the statistics imply a constant stream. The correction makes 3I Atlas a unique, gentle anomaly, an exception that proves the rule of gentle fragmentation. But what if its initial bright flash was the rule? What if all interstellar comets flare violently upon first thermal encounter due to their deep time preservation of supervolatiles? Our 3 anomalies gain new statistical weight. The initial violent light is the standard behavior of an interstellar object. The quiet data edit is the human rejection of a new standard. And the gentle fragmentation velocity is the confirmation bias that allowed the rejection to be published. The time marker of May 6, 2020, was when Dr. Avi Loeb publicly suggested that the high frequency of these objects necessitates a fundamental rethinking of cometary origins, adding pressure to the existing data management debate. Where are you listening from tonight? This quiet, statistical realization is perhaps the most profound of all. The universe is teeming with these interstellar fragments, and one of the most visible pieces of evidence regarding their exotic composition, the initial, powerful flash of light, was quietly edited out of the official logbook. We are now left with the deepest reflection, the true nature of the great silence itself. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the 3rd decimal and the 4th significant digit, something snapped. The trajectory of 3I, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3. I-Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's dynamical systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, Impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice, numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The Skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its Skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge. Triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices. the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. Three-Eye Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the Sunday. The universe loves decay, entropy, erosion, fading. But 3-Eye Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3-Eye Atlas aren't random. They're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, Except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new. Faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together. A self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat, echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it. if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning. The quiet compulsion to continue. The physics of persistence. The refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance. Like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, Other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the web's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. Tell them, his final log read, that continuity requires conversation, even with silence. The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the web. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it "not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern, pulses spaced like a heartbeat. Not communication, perhaps, but rhythm, the kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, A small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Our long, quiet voyage into the altered data of 3I Atlas now concludes with a contemplation of its quiet legacy, the enduring, subtle effect this event has had on the way institutions handle future interstellar data. Even though the official published narrative remains one of gentle thermal fragmentation, the initial, unedited observation, the phantom brightness of 16.0 magnitude, has become an internal, quiet reference point for a very specific type of anomaly. The unseen truth endures, not in the public records, but in the institutional memory of data analysts and computational astrophysicists. The enduring legacy is the quiet recognition that interstellar objects are an entirely new class of phenomenon, demanding a new, less conservative approach to data processing. The experience with 3I Atlas, where the gentle fragmentation velocity was used to effectively filter out the bright, exotic light, data has led to a quiet shift in protocols. Future interstellar observations, especially those from upcoming missions and telescopes, will likely be subjected to far less stringent calibration adjustments, or, at the very least, any such adjustments will require a much higher burden of proof to be filed as a systemic error rather than a physical discovery. This internal shift is the quiet victory of the original data. The very fact that independent researchers continue to debate the discrepancy between the initial photometric logs and the final, published narrative confirms that the unseen truth has a long-term endurance. The quiet humor here is that the effort to create a smooth, predictable story only served to create a more compelling, enduring mystery. The time marker of December 1st, 2025, finds the scientific community still quietly watching for the next interstellar visitor, knowing that the real story may be hidden in the noise, the initial, strange flicker of light. This final contemplation circles back to the mythic link of the cosmic archivist, the figure who recognizes that history is less about what is officially recorded and more about the fragments that survive the quiet edits. The three anomalies, the violently bright light, the truth of the exotic core, the quiet data, edit, the human desire for order, and the gentle fragmentation velocity, the gentle reality of the breakup, have established a new pattern. Any future interstellar object that shows a brief, impossible surge in activity, followed by a gentle physical demise, will immediately be cross-referenced with the 3I Atlas initial data, forcing the issue of exotic hypervolatiles back into the foreground. The deepest human reflection lies in the nature of discovery itself. Scientific progress often occurs not by finding what we expect, but by wrestling with the data that simply refuses to fit. 3I Atlas presented a piece of data too bright, too fast, and too strange to be accepted immediately, so it was quietly filed away. The quiet legacy is that the file is not permanently closed. We are left with the awareness that the most profound secrets of the galaxy may not require a colossal effort to find, but merely the courage to trust the strange, fleeting flicker of light, recorded in the quiet first moments of an interstellar encounter. The quiet, enduring anomaly is the final, essential lesson. The universe is under no obligation to be simple. We may already be part of the experiment, gently observing the quiet processes of cosmic decay and formation, knowing that the true story is often a little louder, a little stranger, and a little more wonderful than the orderly logs suggest. And so, we conclude our long, quiet voyage into the deep archives of celestial mechanics and human interpretation. We have chased the light of a tiny, broken snowball, tracing its hyperbolic path from a distant star system to its final, gentle sigh of dissolution near our Sunday. We have learned that the universe is vast, cold, and immensely patient, but our own records of it are often hurried, warm, and full of the quiet, subtle corrections necessary to maintain a sense of order. Remember our ancestors, who survived a soup of early Earth's toxic atmosphere and the quiet terrors of a dark, unpredictable sky. We are their descendants, seeking quiet truth in the faint echoes of interstellar passage. As you settle into the deepest stillness, recognize the enduring nature of curiosity. The light was edited, the narrative was smoothed, but the quiet question remains, patiently waiting. History bends, but the physical laws that govern the stars never break. Sleep now, knowing that the great silence of the cosmos is always there, and its archives are full of beautiful, messy, and enduring truths, waiting for us to find them in the quiet dark.